Hi again. My name is Kevin Oliver. I'm the marketing program manager for IBM's hybrid data management portfolio. And as organizations are experiencing unexpected challenges in today's environment, good data and good data management have become even more critical. IBM has been a pioneer in data management for over 40 years. We also have been a pioneer in the area of artificial intelligence, or AI. And what we do is we look to work with our customers throughout the world to help them transform their businesses to be able to make this move, this digital transformation journey, helping them with the AI initiatives that they're planning. And we've seen that also that AI has this important symbiotic relationship with data management. And AI is being applied in data management to make it more powerful and efficient for organizations. It's also a critical factor in helping organizations develop and deploy AI initiatives. So having this data management platform that is built for AI, for developing AI, is critical. Today, we're going to be looking specifically at 3 ways data management is actually driving AI initiatives. We'll look at these 3 ways, and we'll also consider how this can help organizations, particularly these days as we're facing these enormous economic and social challenges going on. We'll also explore how during these challenging times, how AI and data management can help organizations continue to do business and become even more resilient and even stronger as they face these headwinds. I'm happy to introduce to you all our speakers for today. First is Mike Gualtieri. Mike is a VP and Principal Analyst at Forrester. His research focuses on artificial intelligence technologies, platforms, and his key technology coverage areas are AI and emerging technologies that make software faster, smarter, and transformative for global enterprises and organizations. He regularly advises enterprise decision makers and executive leaders around the world on the intersection of business strategy, AI, and digital transformation. He's sought after as a speaker with 25 years of experience in the industry, helping design and develop mission-critical applications across a number of industries, and for organizations including NASA, eBay, Bank of America, Liberty Mutual, Nielsen, EMC, among many others. And he also personally has a background as a practitioner. Mike has written thousands of lines of code, managed development teams, and architected complex systems. Our second speaker also on for this webinar is Sam Lightstone. He is a CTO for data and AI at IBM, and he's also an IBM fellow and master inventor. Sam has led a number of technical teams in product development for relational databases, data warehousing, big data, cloud computing, analytics for IoT, data virtualization, data movement, and machine learning. He co-founded the IEEE Data Engineering Work Group on self-managing data systems. And Sam has more than 65 patents issued and pending, and has authored over 30 papers and 4 books. Sam will, today for this webinar, Sam will be speaking first on what those 3 ways data management is driving AI initiatives, give a very high-level overview on that. Mike then will speak to the broader background on data management and AI and how that is working today. We'll have a panel discussion between Sam and Mike, where we'll be looking at 3 key questions that companies are facing today, organizations are needing to deal with as they're being disrupted. Sam will then come back and give some very specific examples of the 3 ways data management is driving AI. And last, we'll have a brief Q&A. So we'll be working through all of that. Before we start, I want to go through a survey question. So we'll be looking at that survey question next. I'm not sure if it's been pulled out. Needs to be pushed out. The question is, this for the audience, what best describes your current occupation? So if you could look through this and then just click into this poll, what role you play in your current occupation. I'll give you about a minute to be able to respond to that. Okay, as we're looking at it, it looks like large group of business partners, which is great. We have a good group of data scientists, AI developers, and non-AI developers. I think between that group, there's probably at least a quarter. And then data architects, data administrators, students, good. And then also press and analysts is wonderful. So good, thank you. Okay, and now we'll go ahead, Sam. We'll move on to the next slide, and we'll take this over as far as explaining from a high level the three ways of data management is impacting AI.
Great, thanks a lot, Kevin. So our thinking has evolved on this topic of AI and data management over the last year, on not only at IBM, but I think across the industry. And, we've now come to think about this space along three different vectors, or three different axes, each of which is very important, each of which is quite profound. Let me walk you through the three different ways, or three different vectors. The first is this idea of operational simplicity, operational automation and optimization of performance. And in this vector, what we seek to do is to use AI methods to make IT and make data management so much simpler than it has been in the past. You may often hear in the industry this term autonomous database. It's one flavor of this axis. So this is all about, this first axis is all about infusing AI into the data management layer so that the system does everything it normally does, but so much more simply, so much with such superior optimization. And what's interesting about this vector is, it gives you performance, it gives you simplicity. It's not necessarily about changing any of the function that's available in the data layer. The second vector is all about raising the semantic sophistication of data systems. And along this axis, what we're trying to do is to raise the sophistication of the data layer so that you can begin to interact with it in a more human manner. And here we're using AI systems, deep learning systems for natural language query, for AI models within SQL, so that you can start to do more sophisticated things with the database and interact with it in simpler ways and more human ways. And we'll have some demos of these things along later in this webinar, so you can see exactly what I'm talking about. But briefly, I would describe this as being more human. Let's see if we can make the data layer more human. So it's starting to add new function, unlike that first axis that was all about infusing AI to make the system better at what it already does. The second vector is about raising the sophistication, making the system more human. And the third axis is, can we build data layers that are really optimized for AI, that meet the needs of the data scientist? And what's interesting about this third vector is that if you look at the history of data, these data management systems began, in the 60s and 70s as transaction processing systems. Getting into the late 80s, early 90s, we see the advent of analytics systems. Getting into early 2000s, we see the advent of big data systems. But none of these systems were really designed historically over the past several decades to meet the needs of the data scientists. And so along this third vector, we begin to explore what does it mean to build data systems that are built for the needs of AI, built for the needs of the data scientist. And that includes topics like how much of data science can be done inside of the data repository, pushing the work close to the data. And we'll explain later on why that's important. It also includes making data accessible to the data scientist through methods like data virtualization. And it can also include different paradigms for data access, not only on structured data, but also pushing data science into the repository for different, for all the varied data formats and schemas that you might have, whether that's relational data or image data, audio, video data, graph data, and NoSQL data. So these are the three vectors. Again, infusion of AI to do what we already do, but much better, much more simply. Number two, raising the semantic level of the system to make it more human. And number three, building systems that are the best possible design and architecture for the needs of the data scientist. So with that, let me pass it over to Mike to walk us through some thoughts on where the industry is going.
Thank you, Sam. And hi, everyone. My name is Mike Gualtieri, Principal Analyst at Forrester, and I cover artificial intelligence. And I just want to give you a very quick backdrop of why it's important to think about today's databases and AI together. And the backdrop is really the priority of most large enterprises today, which is digital transformation. I mean, it's a buzzword, but it's also real. Our data shows that this is still on the minds of companies, and it's a top priority for global enterprises. And what they're trying to achieve here is to either stay or become leaders in their industry. So there's an industry focus on that. And when we ask them why, what they hope to achieve from that digital transformation, the results are expected: better customer experiences, better operational efficiency and productivity. But what's interesting here is that, and I don't have the slide, but when we ask companies what their goal is with AI, they're exactly aligned. And they hadn't always been that way, right? Because 3 years ago, if you asked the AI question, they'd say, well, this is new products and services. And you can see that still makes an appearance here. This is good, especially in today's environment where it's important to keep customers. It's important to be as efficient as possible. And this is why enterprises are embracing artificial intelligence. Our data at Forrester shows that about 54% of large enterprises say they've adopted it in one form and another. And it's also inextricably linked to digital transformations. Our data shows that around 70+% say that AI is a critical part of their digital transformation efforts. And of course, if you think about it, artificial intelligence is fundamentally a data analysis technology, because that's how machine learning works. And it's a huge prerequisite to AI success. Data represents all of the physical events to the extent that we're capturing those. It represents all of the digital events that are occurring, whether it's e-commerce or automatic transfer of information company to company. It represents what's happening with customers. It represents what's happening in the market. It represents all of the business events that are occurring in the market with your company and with your competitors. So artificial intelligence is all about the data, because what we do with that data is we can reveal insights about customers. We can reveal operational insights. We can reveal business insights that help us make decisions and help us automate processes and interactions with customers. And there's a lot of talk about algorithms, but it's really the data that's important. But it's also the challenge to AI. And the old adage is always true in computer science and applications, and also in AI: garbage in, garbage out. The good news, though, is that global enterprises actually have a tremendous amount of rich data. If you think of the average large enterprise and you ask them a question, how many applications do you have running your organization? It's in the dozens, hundreds, and often thousands through mergers. And all of those applications are in some way responsible for originating data. So the good news is that enterprises have lots of rich data sources that you need to do effective artificial intelligence. And you can see just a sampling up here. It's a little bit mind-boggling when you take each one of these data categories and think about and even drill down. So there's plenty of rich data for AI. That's the good news. But the challenge is that it's often in silos. And this is the age-old problem of data. And even doing non-artificial intelligence projects like business intelligence. And when you have all of those data silos, that slows down the machine learning process. And I don't mean slow it down technically, but the entire process of acquiring and taking all of the steps that you need with that data. data architectures were not designed. They were not designed for artificial intelligence. They were designed for business intelligence, and the type of business intelligence that is not necessary today or tomorrow or weekly. It was designed towards monthly reports, weekly reports, essentially reporting. So less real time. And the problem with those architectures is that it's too slow, and data science teams and AI teams can't get the data fast enough. So a new approach is needed to sort of grease the skids to reduce the friction of getting data out of those silos and to make that data available to those who need it. So there's many traditional approaches to doing this, traditional ETL, data lake approach, but perhaps the fastest way to do it for many use cases is to actually do AI, where that data originates. And more often than not, it's in a database. And so we call this the AI database. The important thing to understand about an AI database is that an AI database has to have all the goodness of ACID transactions. It has to have all the goodness of databases that we know and love today, but it has to add AI functionality to it. And this can be a bit confusing, and even in our definition requires some explanation. So we say AI databases, they use AI itself to automate database, to provide better querying of that database, but also to use the data in that database for data science, to do AI for those teams. So we avoid a lot of movement of data. Now, this can be very confusing because there's two uses for AI. There's AI to manage the database, to make the database easier to automate the administration, to reduce the cost of managing that database, to make it more elastic. And that is the automation. So that is using AI to make a better database. And then there's the AI which democratizes queries by using natural language understanding. SQL is a well understood query language, very well understood by a certain population, certainly by developers and more technical business intelligence people. But even that can be quite complex. Well, the good news is that AI can be used to query very complex data with natural language query. So that's sort of a second use case here for the AI database. And the third use case is to embed data science tools within the database, right? Because if you don't have to move all of that data, or if you can make that data available through data virtualization and other technologies, then you can accelerate the model training. And model training is the part where you actually build an AI model that's used in the application. And typically that process for data scientists, they have to go outside. They have to take data from the database, put it somewhere else, perhaps even another database, combine it. So when you think about where does data originate, what if we could train models where that data originates, or make it available through virtualization where it originates? You should be able to dramatically speed up that process. So, what we're telling enterprises who are trying to accelerate the number of database use cases, AI use cases, we're saying, look at your current database. Try to understand what sort of capabilities are being built into it that take advantage of AI itself, but also make the AI development process that much faster. We have seen digital transformations are being powered by AI use cases. We think that there's literally 1,000+ use cases within existing business processes and applications. We think most companies are doing half a dozen, maybe a dozen. I talked to many companies that are doing a couple of hundred use cases, but there's many, many more to go. So you want to accelerate that as fast as possible. AI databases will play a big role in making that happen faster. And now I'll turn it back over to you.
Hey, Kevin, are you there?
Yeah, I'm sorry. Can you hear me?
We can hear you now. Yeah, go ahead.
Okay, great. Good. Now we're going to spend some time. Thanks, Mike, for that. Now we're going to spend some time as far as on a panel discussion with both Sam and Mike, talking through this concept of the AI database and applying AI to data management. The first question that we're going to be bringing up is this: how can an AI database enable organizations to more rapidly respond to changes in the economic environment? And this is addressing particularly right now when there's a lot of things going on because of particularly with the COVID-19 virus, all the things that are happening to business and to society that are very challenging for organizations just to be able to make a shift to continue to be available and resilient. So I wanted to see what both Sam and Mike, what you think on this as far as how can an AI database enable organizations to rapidly respond?
Yeah, maybe I can start. I think that if you look at what's going on today and the impact of COVID, and COVID's, it's just it's major. It's maybe the most major economic disruption that we've had in 100 years. But there have been others to a lesser extent, and there will be others in the future as well. But if you look at this current crisis, you see that people are looking for two things. They're looking, number one, for cost savings. People are shifting their investments from, building up the future, which they were hoping to do, and shifting a lot of that energy in the short term to tactical cost savings. That's one dynamic that's going on. The other dynamic that's going on is people are looking for insight. They want to understand their businesses and where the market is going, where the industry is going, how everything's changing around them. And because it's changing so fast, they're desperate for insight onto what's going on. And so with those two dynamics going on in the market, and probably everyone on this call has got some of that going on in their own organization, the cost saving and the desperate search for insight. The AI database really can play a great role in both of those. First of all, in the cost savings, if you look at those three vectors that I spoke about, and Mike touched on the same concepts actually. Remember, just a reminder, we have the three pillars, right? AI infusion to make things simpler and faster. Well, simpler and faster is cost savings. The second pillar was raising the semantic layer, the semantic capability of the data layer, so you can begin to interact with it with less skill. Rather than needing to know Python or SQL or R, you can now start to interact with it in a simpler way, such as typing in English. Just simply ask an English question or natural language question. And that's cost savings again. And the third pillar was, empowering the data scientists, moving the data scientist's job into the database so it's faster, more efficient, less security concerns. And that gives us, that profound access. It empowers data scientists. They get faster access to insight, which is one of the key, if not the key, purposes of data science. So I think if you look at all three vectors, it's actually very well suited to this economic shift and the dynamics we're seeing around cost savings and the desperate search for faster insight.
Yeah, and this is Mike. My take on this is that what's paramount to companies is operational efficiency. Got to look for efficiency, and when you think of an AI. When you think of AI's role and efficiency, there's two ways to look at it, right? There's how can I augment my workers' intelligence to make them more efficient? That's use case number one. Use case number two is how can I automate intelligence within existing applications and business processes and make those decisions and pattern detections much sharper than they were, right? So if it's business as usual, meaning the use cases we had before this event, we're just going to march on, that's fine, right? There's processes in place. But if companies are looking at their entire internal operational landscape for use cases, they have to have use case flexibility for AI. Because typically when you find a use case, you have to identify data sources that are needed to implement that AI use case, and you have to gather them. But often it is centered, the data that's necessary to do that use case is centered in some existing operational database, which is also an operational transactional database, perhaps even analytical as well. So the idea that you could train the models within that operational database takes many, many steps out of the process, right? Because now you don't have to find a place to move it. You don't have to ETL it. You don't have to do all of this other stuff. You can use queries to do the data set. You can do feature engineering in place. All of the steps of data science you can do in that database. And perhaps there's some other sources you have to bring in. You could bring those in, or you could represent those as virtualization. So it gives you flexibility in that regard. Now, the other thing that's critically important to understand about AI, and when you train, we always talk about training the model. It's never, ever one or done. You have to retrain the model. Because as newer data enters the system, that model, that initial model you deployed, can drift, right? So what better place to retrain the model than the place where the newer data originates, right? So there's a key advantage to being able to train the initial model in place, but it doesn't stop there because you're going to have to retrain that model periodically. So it reduces the complexity not only of the initial training, but of the retraining thereafter. Now, this isn't a panacea for all AI projects, because some AI projects have to gather internal and external data. It's a more complicated environment, but there's many use cases. I would say, more than half of them are centered around data that exists in an operational database.
Okay, great. So just kind of in summary too, as far as this aspect of automation being very important in training the model, and as far as not only training the model initially, but the retraining of the model afterwards. I'm thinking with Sam's points as well around the aspects of cost saving and looking for insights into what is going on. Some of the capabilities that the AI database gives you for that would help you to more rapidly respond. So that's exciting. The next one is next question I wanted you guys to help us with is, in what ways could an AI database make organizations more easily recover from challenges they may currently be facing? So now that they've entered into this new environment, how will they be able to recover and be back to work more quickly and back to revenue and profitability, all of those things?
Well, I mean, I certainly think that, as Mike said, the automation is huge, and it allows companies to get moving faster when you don't have to have a huge amount of skill to get something done, and you don't need weeks and weeks to figure out how to get something done. So when systems can manage themselves, so to speak, when they're infused with AI, you can get back to business a lot more quickly. But I also think that getting back to business, there's another element of this, which is it's not going to be the same business. Like the world is going to be a little different when we come out of this COVID situation. It's not going to be quite the same world we had in let's say, January of 2020. And none of us knows exactly what that's going to look like. So that's where the insights that we get from data science really help. Because it'll help us understand this new world. It'll help us understand our customers, our supply chain, our business-to-business interactions, and we'll be able to respond more quickly. I mean, that's really why all this data science theme has caught on over the last 5 years in the first place, as people were hungry for that insight. But now, in such a dramatically changing world, I mean, changing over the space of days now, not just years, it's going to be a different world. None of us knows what it's going to look like, and data science is going to help us understand it and respond to it. So I think that these technologies, and not only the AI database, but other AI technologies, are going to be hugely powerful for us in getting back to business, and getting back to business in a way that we don't yet understand, a way we don't yet know what it's fully going to look like. Now, Mike, what do you think?
Yeah, I agree with that. And I think it's not just about the database, it's AI in general, is what is the impact? And one of the questions I get asked a lot is, well, what do you think companies are going to do with AI? Are they going to say, oh, forget it, we've got bigger fish to fry, or are they going to double down on it? So as I like to say, are they going to hold, fold, or double down? And based upon the interviews that I've had with companies so far, there seem to be two minds. Enterprises that have successful implemented AI, and usually when they have, it's a use case that is very consequential, right? Save $70 million a year, save $16 million a quarter. I mean, there's a consequential use case, single AI use case. Those companies feel like they understand the value of it. They feel confident in their ability to implement use cases. And so their plans are not going to change. They're going to continue to implement those use cases. And in many cases, their hope is to accelerate the number of use cases because there's tangible ROI. Now, the other side, though, is companies that maybe have dabbled. Maybe they're in AI POC purgatory. And they're looking around the organization. They're saying, well, where should I put my dollars? And they're saying, well, we don't really know how to do this. So maybe we delay on AI projects. They're probably the ones that should do it, rather than delay the investment, because otherwise they're going to fall behind in their industry and their competitors that are more mature at this. So that's one way to look at the AI landscape and how companies are thinking about it. And then the other way, which is a more tactical way, is how are data science teams going to get more efficient? And that's where we think things like AutoML will be more accepted because it reduces the time to create a model. And that's why they have to think more creatively about the data side of that, because the data side of that is a huge prerequisite to doing the modeling. So we think that data science teams that are maybe familiar with a certain way of doing things are going to get more creative, more efficient, and the AI database is one way to dramatically reduce the data acquisition and the data prep process necessary to do a use case.
Great. Thanks, Mike. Okay, we're going to move to the next section with Sam. Sam's going to go ahead and give some illustrations along the lines of these three different ways. Sam, are you ready?
Yeah, I'm ready. Let's see it. Okay, this is the exciting part for me where I get to show you guys some demos. So what I'd like to do over the next 5-10 minutes is actually show you a demo of technology in each of these three pillars that I talked about, and Mike also talked about. So you can see it in action. I don't have time to demo every single bullet that's on this list, but I chose one technology from each of the three to help illustrate what we're talking about. So let's talk about the first one, which is this notion of AI infusion. We're going to infuse AI into the data layer so it's operationally simpler, so it's operationally faster. And not necessarily adding function in this vector. We're simply making it do what it already does much more simply and with much better performance. So in this first demo, what I'm going to show you is an example of a data system that can actually learn from experience to produce better, faster query performance. And what we're actually doing in in this technology is we're infusing AI into the query compiler of the database, which is the component of the data layer that decides the strategy to execute a query. Now, these queries, whether they're queries for analytics or queries for data science, they can be quite complex. And the interesting thing about these queries is that usually there are thousands, if not tens of thousands or even millions of strategies to execute a query, and they're all correct. They all give you the right answer. So a user may submit a query expressed in SQL, for example, and there's an answer that's associated with that query. But from the time the query is expressed in SQL to the time you get an answer coming out, inside the guts of the data layer, the system is trying to figure out what is the best strategy to get that answer, to compute that answer. It's a little bit like driving to work. Lots of different ways you can drive to work in the morning. You can drive from, you take the highway, you can take side streets, you can go around town. And, but one particular strategy is going to be the optimal one. And one of the major purposes of the data layer, one of the things it tries to do is to determine what is the optimal strategy for getting you that fastest possible answer to your question that you've expressed in some language, whether it's natural language query or SQL or Python, whatever you're asking. So that's the problem. And for years, there's been, classical technology to deal with this. Cost-based query optimization has been the state of the art. Here's a particular query that I'm going to show you a demo or show you some illustrations around. This particular query is going to join 4 tables and produce a result. We tested this query along with several others around. Actually, am I showing this is the video here? Or we're showing the video now. Okay, so we're about to show you the video, and here you can see the idea of infusing AI technology, artificial neural networks, as they're known, into software. So this is a technology that came into the fore in the 1980s, artificial neural networks, and really is formed some of the backbone of AI technology today. So in what we're doing in this next demo is we're infusing artificial neural networks into the data layer to see if we can come up with better execution strategies than were previously found with the classical techniques of cost-based query optimization. So, and here you can see some of the output. On the top, without machine learning, there's a strategy to produce a result for that query. It joins 2 tables, it joins 2 other tables, it joins the results of those 2 tables and produces a result. Now, if you're not a data geek, this may seem a little abstract, but the important point is this. The strategy to compute the best answer, the fastest answer on the top with classical methods. On the bottom, we see that the system with AI infusion found a different strategy. And whether you can follow whether you're familiar with that illustration or not, that notation, don't worry about it. The point is it's a different strategy. It's a different strategy, and the strategy on the bottom actually ran much faster because it's learning from experience. These AI systems learn from experience and they get better over time, unlike the classical technologies that were based on statistics. So let's look at an actual live demo now of this. I'm going to show you a system that's used for fraud detection and looking at the rates of fraud across the United States and the density or the frequency by state. And on the left-hand side, you'll see the query running with AI infusion. On the right-hand side, you'll see the same query, the same hardware, and the same data using classical query compilation techniques. And let's see how they compare. Here we go. We're actually going to run this twice. So let's go and see this in action. Okay, it's taking a little bit of time to load. Here we go. Okay, so you see the query on the left is already finished, and the query on the right is still going. It's still going. It's going to take some time, and now it's finally finished. Let's run that one more time. Same query one more time, head-to-head. AI infusion on the left is done. And the classical technology with cost-based query optimization, which is a fancy way of saying statistics-based strategy, is finally finished. And when you compare the two, you actually run the numbers to how different that performance was. In both cases, it was more than 8 times faster on the AI infusion. So these are very, very dramatic performance benefits. And that's just one example. We have many similar technologies that we're building around AI infusion into the data layer. But I think that's quite a profound one and quite disruptive in the database space. That technology I was comparing against, by the way, again, there was AI infusion is the new technology. The older technology is the cost-based query optimization. That technology has been around. The cost-based query optimization was invented in 1979. Has been the gold standard ever since. That's amazing longevity for any technology. So here we have a technology that's been matured for over 30 years, and still we're able to completely blow that away with AI. Let's look at the next pillar. The next pillar we talked about was raising the semantic sophistication. So now we're looking at moving away from languages like SQL that require a fair bit of skill. And by the way, there's a lot of people in the world that know how to code in SQL, which is great, but it's still tiny compared to the number of people who know how to speak in natural language. Because everybody knows how to speak in their mother tongue, right? Whether it's English or Spanish or French, whatever you speak. But basically, everybody can ask a question in natural language. Only comparatively, a very small number of people know how to communicate in SQL, even though it is still very popular as a language. So in this next example, we'll see a system that accepts input in natural language. You simply type a question similar to asking a question in Google, except it's not Google. It's your database. It's a relational database that you're speaking to. And by the way, that could be a single database, or through the power of data virtualization, it could be a dozen databases of different kinds. It could be a mix of DB2 and Oracle and Informix and SQL Server and big data systems like Hive. So let's have a look at this. It's called the DB2 Augmented Data Explorer. Not only is it going to accept input in natural language, but as you're typing your question in natural language, it's going to immediately start to visualize the results for you and select the optimal visualization of your data. So the question you should ask yourself is, how would it change your business if instead of a very tiny number of people in your organization who knew how to code in SQL, what if everybody in the organization who could type an English question could start to get access to your data, and how that would transform your organization when so many more people can get access to insight. Let's have a look at the Augmented Data Explorer in action. So in this demo, you'll see we'll start typing a question in English. And similar to Google, actually, as we start typing it, it immediately starts to sort of look ahead at what the answers might be. It begins to look ahead and predict what question you might be asking. Number of it begins to suspect you may be asking questions about customers or customer values. Let's continue asking the question. I've got some delay here on the refresh. I'm not sure why. Let's give it a minute to catch up. Okay, now we've got a visualization of the data. We can look at it as a pie chart, as a bar chart, or as tabular data. We can sort the data. So that went by pretty quickly. I personally, on my end, I had a bit of a visual delay. I hope you guys did not. But in that very short demo, what you saw was we were able to ask a question about customers by region and get a visualization as a pie chart automatically without our even asking or suggesting what the visualization should be. And then we were able to change our mind and look at the data in other formats, such as a bar chart or tabular form. So very powerful. I didn't need to know any SQL to do that. I could just type a question in English. So let's go on to the third vector. And here I'm going to geek out on you a little bit. So if you're not familiar with data science and Jupyter Notebooks, this may be super geeky for you. But for those of you who are hardcore data scientists and really into the technology, we're going to go a little deeper now with this last demo. And I mentioned earlier that in this third vector, what we're looking to do is ask the question, what would it mean to build the best possible data layer for the needs of the data scientists? Now, one of the things that we want to be able to do in this layer is bring the data science as close to the data as possible. There are a number of reasons why this is beneficial, and Mike touched on many of them already. First of all, it's a lot faster. You don't want to have to, if you have to copy data out of the system, you're slowing yourself down. So when you can push this work closer to the data, you can get a lot more done faster. Second of all, often when people pull data out of the system, especially these large data sets, if you're dealing with you're dealing with big data, terabytes and petabytes, it's simply not practical to bring it all out of the system. So what data scientists usually do is they take a sample and they build a model on a sample. Well, that's very limiting, because if you're operating on a sample, then your model is not reflective of the whole. It's not even, you end up with a pretty weak model if you're just building it on a model that's based on a fraction of a percent of the data. But there's another element of all this, and why it's beneficial to keep the data science close to the data, which is a security and a policy consideration. I was just speaking with fairly recently with a large bank, and they said to me, part of the reason that they love this third pillar, the AI database and the database that's built for the data scientist, is because they don't actually want their data scientists to be copying all this data out of these very sensitive data systems onto their laptop and building models there. Because, it's just not, from a security perspective, in terms of where the data is flowing, who has access to the data, controlling access to data, it just breaks all kinds of rules for them. So they much prefer to keep the data science activity encapsulated in the data layer and not have that data coming out onto other systems. So so let's look at a demo now. We're going to build a decision tree classifier inside of a Jupyter notebook. This is very classic stuff for people who are familiar with data science. If you're not, follow along for the ride. But Jupyter notebooks are, amongst the most popular tools in the world for data science, and decision tree classifiers are one of the classic models. Now, what we're doing differently in this case is that even though we're using a Jupyter notebook to express our analysis and building of the model, training of the model, all the actual work is going to stay inside of the database. This is entirely in database. We're going to go through a process of looking at the data, the statistics of the data, modifying the data, separating the data into training and testing data sets, normalizing the data, building the model, deploying the model, scoring the model, evaluating them. We're going through the whole thing in about 4 minutes. So buckle up. Let's come along for the ride. In this example, we're actually looking at a data set that represents the survivors of the Titanic, the massive ship that sunk all those years ago. And we want to build a predictive model to say, help us predict whether a person was likely to survive or not survive. Now, it's a little bit academic, of course, since we obviously know exactly who survived and who didn't. But, for the purpose of the exercise, we're building a training model to predict survivability from the Titanic. So that's the demo we're about to watch. So let's deploy this demo right now and have a look at data science inside of the DB. So again, at cell 3 of the Jupyter Notebook, we connect into the database. And then at cell 8, we begin to explore the data by starting with the column properties function that gives us a basic view of the columns, their values, and we can start selecting out which of the features of interest which are missing data. After that, we're going to go on to cells 10 to 16 in this demo and invoke the runstats function to get a much deeper view of the data, and specifically the distribution statistics on all of these columns, and start to visualize in a much more profound way what is the data that we're dealing with. We can also, at cell 17, invoke the correlation function, start looking at the pairwise correlation for each of the numeric features in the data set and some of the visualization of that data. Okay, fantastic. Now, let's go ahead to cells 18 and 19. So in cell 17, you see the correlation output. Great. Let's go ahead now to cells 18 and 19. And we're going to invoke the split data function so we can automatically split our data into training and validation sets. And this is one of the major functions of the data scientist, because, of course, you don't want to build your model on all the data. You want to build it on a on a training portion, and then a validation portion will come later. So this split data function does that for you automatically. All right, now we've split the data, and now let's go ahead to cell 22. In cell 22, we're going to invoke the impute data function, which is going to fill in the blanks anytime we had missing data, which is very common. Missing data. So impute data will fill in the blanks with either mean values, median values, or frequent values. And at cell 25, we'll invoke the std norm function. So we begin standardizing or normalizing the data. So all the data has a consistent range. Again, very standard thing to do in data science. And cells 29 to 30 will begin to apply discretization to the data, moving from a continuous domain to a smaller number of discrete domains. I'm just showing this as examples of very common data science operations on the data. And all that is just by way of preparing the data. Now we're ready. We got training, and we got the training data set. We've adjusted it. We've normalized it. We've discretized it. And now at cell 32, we can actually build the model by calling the grow decision tree function, which is actually build the decision tree and create our machine learning model. And at cells 34 and 35, we can actually evaluate this model with the predict decision tree function, see how well it performs, and also call the confusion matrix function to build the confusion matrix, which shows us how often the model was predicting correctly or incorrectly. And at cell 37 of the Jupyter Notebook, I know it's going by pretty quickly. In cell 37, we see the evaluation of the model, and it shows us that we can predict who's going to survive on the Titanic with 76.4% accuracy. Woohoo! Now, all that was pretty geeky, and it went by pretty quickly, but I just wanted to show this to you so you can see, using a standard tool like Jupyter Notebook, all the data science was done inside of the database. I didn't need any special version of Jupyter Notebook. It was a standard off-the-shelf Jupyter Notebook. I was able to connect into this database and do all the machine learning. I could do all statistical analysis. I could do all the data preparation and transformations, normalization, discretization, building the model, deployment of the model, evaluation of the model. All of that was able to happen inside the database and huge improvements to performance and security protocols. And I could build the model on a complete set of data or a much larger set of data than if a data scientist had to copy it all out. Okay, so just to wrap it up, I think we've touched on these three vectors, these three ideas of the AI database, and a lot of power that comes from these three things. And I've showed you demos for each of them. The operational simplicity and performance by infusing AI into the data layer. Number two, raising the semantic sophistication, be more human. And number three, building data systems that are built for the needs of data scientists and AI. So I hope you enjoyed that. I apologize for the technical glitches, but hopefully it looks like we got through it okay. And with that, let me turn it back to Kevin.
Thanks, Sam. I appreciate these demos of showing the different ways that data management is impacting AI. And it's we don't have a lot of time for questions. I wanted to pull just a couple that did come up in the question and answer, just for the two of you to be able to respond to, and then we'll be done with the webinar for today. One is one that was an interesting one is, what is the best way to ensure ethical AI use is put into practice, right from the initial setup of the database and into the through to the development of the AI modeling itself?
So the question was, how do we enforce ethical use of AI?
Yeah,
that's a super tough question. I personally don't have. By the way, it's not only a question about AI. How do you ensure the ethical use of data? And so I don't know that the problem is
right.
Unique to AI. AI maybe just makes it a little bit more scary because AI can do more with the data than was previously possible with simple BI systems. But I don't know that it's unique to AI. So the question of being ethical use of data is an open question. I hate to say it, but one of the approaches is first of all to define as a community. We need to define what we mean by the ethical use of data, and what is the ethical use of data, whether it's for AI or BI or any other purpose. So defining it is probably step one. There have been many technical leaders and business leaders who have called for a certain amount of policy and legislation in this domain. And I know that's somewhat politically charged. A lot of people don't want, politics and the law getting involved. But on the flip side, it is one of the effective ways that, as a community of human beings, that we organize ourselves to do the right thing. So that's certainly another approach. But I'll tell you, to be honest, what I worry about most is not so much the corporations doing the wrong thing, but much more scary is how do you control, the 14-year-old in the basement who doesn't know or doesn't care about what they do with data. So it's a much harder problem. I don't know, Mike, what do you think?
Yeah, I mean, I get this question a lot too. And the thing is, there absolutely is no universal definition of ethics, because that's, it's different. It's even different in different societies. So, I mean, so the first thing is, like you said, Sam, you have to define what it is, not just universally, but what it means in a market, because there's one thing that could be seen as ethical in one market and not be ethical in another. So this is very, so it's very, it can be very regional, and it can also be different for different companies. So, A, follow the law. 2, understand what your as a company's ethics are, and then you're going to have to map that down to how you use the technology. But I agree with Sam. This is a question for software, right? Just software in general. How do you determine if software is ethical? Now, getting down into some of the nuts and bolts of this, one of the big ways to once you define what your ethics are, how do you enforce it? And in machine learning in specific, there are some techniques that have emerged. They're called explainability techniques. One's called Shapley and others called Lime. And there's these are techniques that can determine, what data was actually used to make the decision, right? So you want to explain how the model was trained and what data was used, but you can also monitor. Actually, IBM has something called Watson OpenScale.
Yeah, exactly. I was going to mention that.
Right.
Yeah, OpenScale shows you not only how it did what it did, but it shows you, by the way, if your data is drifting from the models, your model is becoming stale over time. But interestingly, what OpenScale shows you is it shows you why. Why did the AI make the decision that it made? It was very powerful, and it helps you trust. Now, how do you know you can trust the AI? You can trust the AI when you can see why it does what it does. And so OpenScale, for a huge range of machine learning models, will help us understand exactly why AI is doing what it's doing. Now, if someone maliciously builds an AI model that's going to do something unethical, Watson OpenScale may help us understand that the model is being unethical. But if it was deliberate, it's a whole other can of worms. But at least Watson OpenScale has the power to show us under the hood why AI models are doing what they're doing. So that's a huge step forward.
Okay, great. Well, thanks, Mike. Thanks, Sam, for your help today on this webinar, and we'll be ending it here. Thank you, everyone who attended. We appreciate your time, and hope you have a great morning, evening, or afternoon wherever you are today. Thanks.
Thank you.